This research is about forced vibration analysis of laminated composite plates under the action of a moving vehicle, where the vehicle is a 3 degrees of freedom rigid body and the bridge is modeled using laminated composite plate. Another main purpose of research is studying the effect of rise parameters on dynamic magnification factor. As you can see, the plate has dimensions A, B, and H, referring to length, width, and thickness respectively. Also, the vehicle has 3 degrees of freedom determined by Q1, Q2, Q3, which is moving from left to right. Furthermore, in order to obtain the equations of motion, a 9-node element is considered with 5 degrees of freedom at each node. Having these assumptions, the equations of motion extracted based on first shear deformation theory are solved by Newmark's method. At first stage, free vibration results are provided that show good agreement with those available in literature, and right figures the influence of slenderness ratio of plate on the first 3 non-dimensional frequencies for 2 different boundary conditions with certain dimensions and layup are provided. However, for the case of forced vibrations, the influence of other factors such as plate boundary condition, plate damping ratio, plate slenderness ratio, and vehicle masses on dynamic magnification factor is studied. For this, several non-dimensional parameters are given and the accuracy of results are estimated by literature. In conclusion, the forced vibration analysis of laminated composite plate traversed by a moving vehicle is studied, and the effect of rise parameters on dynamic magnification factor is studied. The equations of motions are obtained based on first shear deformation theory and using finite element methods. The equations are extracted and the Newmark's method is utilized for time discretization. Finally, the forced and free vibration results show good agreement with those available in